23rd of August 2023, India became the fourth country to successfully land a spacecraft on the southern side of the moon, Chandrayaan-3, which translates to Moon Vehicle 3. But why do we need to study the moon? Well, other than the obvious, it's super interesting, it's also because it's the Earth's sister. It was formed at the same time from the same nebula, and it's made of the same things. For example, we can find certain things on the surface of the moon that you can only find deeper down in the Earth. So studying the moon often tells us a lot about the Earth itself. So to reflect on this Indian lunar mission, the Nature Careers editor Jack Leeming spoke with astrophysicist Somak Raychaudhury, the current vice-chancellor of Ashoka University in India. Raychaudhury started his career in astrophysics in the UK, studying at the University of Oxford before completing a PhD at Cambridge University. He took on his first teaching post, which he held for more than a decade, at Birmingham University before returning to India. Because his career has spanned different continents, Raychaudhury has had the opportunity to be involved in several international space missions. For example, working with NASA on the Chandra Satellite Project Space Telescope and with India's Sun mission to develop their ultraviolet camera. In this conversation, Jack and Somak Raychaudhury talk about Chandrayaan-3 and what data it has collected, but also why it is important for India to have done this. They also discuss the history of India's space program and how India is developing its space industry, which leads them onto the launch of its solar satellite, Aditya. The second half of the conversation is about brain drain in India and how they are dealing with this. This interview is part of the Nature Spotlight on India, a supplement to Nature covering the country's scientific and economic development. For more, you can go to nature.com. Somak starts the conversation by telling us about the Chandrayaan-3's history and purpose.
Right, so this is the third mission to the moon. The first one was in 2008, Chandrayaan-1, which went on an orbit around the moon. Did not attempt to land, but it had a couple of experiments to look for water on the moon. And it found signatures of water from going around the moon. So but that gave us indication that one could A, get a vehicle in orbit around the moon. And of course, not many other countries had done that. And B, the ISRO, which is India's space research organization, had the capability of launching a vehicle that did this very complex maneuver of going around the Earth and to the moon in a very long orbit, which actually brought down costs. It's a low-cost mission. So it was mostly an exploratory mission. And then 3 years ago, Chandrayaan-2 attempted to land a lander vehicle on the moon. And that lander crashed in the last minute or so of its landing procedure. It was going all right till it didn't manage to land properly. The orbiter part of Chandrayaan-2 is still in orbit around the moon and is done very good work, still doing very good work. So Chandrayaan-3 was then sent as a follow-up where the number of experiments on the orbiter itself was kept at a minimum because Chandrayaan-2 is already operational, but it was mostly sent as a vehicle to be landed on the moon. And in the last few years, there's been a lot of discussion and analysis on what happened to Chandrayaan-2 so that it did not land. And then the analysis brought up quite a lot of very interesting points, all to do with how the hardware could be improved, how the software could be improved, how the landing procedure could be improved, things like that. It's important because this is one of the first missions to land near the south pole of the moon. The southern hemisphere of the moon, it's kind of the far side of the moon, is largely unexplored. And so this was as far south on the moon as anybody's gone. And so this one, Chandrayaan-3, landed finally successfully at a place which was not far from where Chandrayaan-2 had been unsuccessful, and did its work for 14 days, which is the length of the lunar day. Since then, it has gone into hibernation. We didn't expect to get it back, but the 14-day mission has sent back a wealth of information, and all the instruments that were on the lander worked very well. So we would call it a very successful mission. Not just landing, it did another interesting thing is that it did a little hop. It took off and landed back in again in preparation for future missions, which will actually collect stuff from the surface of the moon and take off from the surface of the moon.
And so you've learned that it can hop So the hope
Yeah,
is that in the future,
that's right.
Chandrayaan-4 maybe will be able to hop off and on.
Yeah. But the scientific instruments that were on this lander has so far worked very well. Of course, the data is being analyzed, but everything managed to work very well. So I think the difference between the 3 and the 2 was amazing. The fact that it had quite a lot of things built into it to make it accident proof, so that it demonstrated that it actually could land and roam around. So there's a rover that roamed around on the surface of the moon.
Can you give us some examples of the kind of data that this spacecraft collected?
For example, the Chandrayaan-2, one of the instruments had shown very convincingly the presence of water in the southern hemisphere of the moon. But it only talked about water being there. We didn't know where it was. There was always a suspicion that it would be in the shadowed parts of these places. The temperature goes down to as low as minus 200 degrees. And so that's where water is supposed to be. So the part of the rover's experiments were to travel around in an area, try to figure out whether they could actually find water. So that's only one of the missions. We don't know whether it's been found yet. The data is being analyzed. But in addition to that, part of the experiments were to figure out what the composition is of the thin layer of atmosphere that the moon has. The moon has a very thin layer of air, and it's also full of charged particles. So there was one experiment that looked at what kind of charged particles there are in the atmosphere. Another looked for the various gases that could be in the atmosphere. Then there's part of experiments also looked at the composition of the moon's soil in the southern hemisphere and looked at the presence of certain minerals in the soil. It also very critically looked at, and this we've seen the data to be very good, look at mild vibrations on the surface of the moon. These are the moonquakes, like the earthquakes, mild moonquakes. So there are a lot of theories about what causes moonquakes. It could be the constant bombardment of the moon's surface because the moon doesn't have a protective atmosphere, bombardment of material from outside that also causes the moon to vibrate quite a bit. But like the Earth, it could be from within. We don't know what's inside the moon. So it could be volcanic activity, lava activity from within the moon that would cause mild tremors. All of these are important with the view to one day having a building, having colonies on the moon, right? If you want us to have establishments on the moon, not just to live there, but maybe as a stop on the way to other places in the solar system, then we would like to know what's near the surface. So these are all experiments designed to start this kind of exploration.
I guess that's why it's significant from the perspective of space researchers. It's why that mission's important to learn that sort of stuff. Why is it important for India? India is only the 4th country to do something like this.
For India, it had more of a way of trying to test the technology that the Indian space program is capable of. The Indian space program has been on since the early 60s. And so in 50 years, what has it achieved? It has independent launchers that is capable of launching complex satellites and payloads up to 4 or 5 tons in weight, which is significant. It also can produce low-cost missions to go to the moon and now we know to Mars. And on the way, you have very complex maneuvers that can go around these particular celestial bodies and also to land on the moon. So it is important for India to demonstrate a lot of this, in addition to the science, because the space industry is growing very fast. The international space industry is now worth more than $600 billion, and India currently plays a very small part of it and would like to play a very important role. And achievements like this go a long way in doing that, to both to show Indians, ourselves, that we're capable of doing it, but also to show the world that there is a lot of space-ready industry that's there, which can take part in international projects.
I understand that recently India started to open up its space research sector to private investment. Can you tell us a little bit about that?
What India's done with the global space industry in mind, India joined the Artemis Accord recently, right? So Artemis is a global moon project, which involves a lot of the industrialist countries around the world who are thinking in the long term about missions on the moon and also activities on the moon. So that's one part of it. And this is one of the largest coordinated space projects that people have thought about. India also has ambitions of manned flights, having its own space station, sending astronauts into space and maybe landing on various parts of the solar system. That's one part. And then, because the Indian space establishment is maybe one of the top 5 in the world, and this almost $1 trillion industry worldwide, which is rapidly expanding, has very little from India in it. So India recognized that because the Indian space activities have been traditionally done by the government-owned Indian Space Research Organization, Department of Space, the government of India, it's not capable of handling such a huge job globally. And of course, since the global space industry is moving towards led by private entities, governments can't necessarily always interact with private entities. So it's very clear that if India wants to play a very important role in the global industry, the activities will have to open up to the private sector. And I think it's only time before we can see major space players coming up amongst the industry in India.
Now, you mentioned that Indian space research and these public organizations started in around the 1960s. Where does that space heritage come from? How did it sort of start?
In the 60s, the missions were technology driven. And even though the Indian space program had started then, it wasn't ready enough to do the exploration of the solar system. The Indian space technology started towards doing remote sensing, the photography from space of weather systems, agricultural land. And this was more driven by India's needs for the space program to serve the key priorities of India. One of the main priorities being agriculture. So Indian agriculture has been amazingly helped by the space mission in India by looking at the terrain of the land, by changing communication between various parts of India, looking at big programs on natural disasters and predicting them, how to manage them and things like that. And so this was the focus of India, and it wasn't really going to the moon. What has now happened is that as a result of the very robust work of weather satellites, of remote sensing satellites, and then communication satellites from the 60s onwards, India has now gained its own launcher program and science program. And scientists got interested in India's space program starting from the 90s onwards. And India's first scientific satellite was launched only in 2015, AstroSat, which has 5 telescopes on it. And India's interest in science from space, which Chandrayaan and Aditya, they're all part of, comes from a very long tradition of Indian scientists and astrophysicists who've been working on ground-based work on astronomy, trying to understand the universe. Now having ways of sending telescopes up into space above the atmosphere. Now, there are many branches of astronomy that cannot be done from the Earth. And these are things like ultraviolet astronomy, infrared astronomy, gamma astronomy, things like that. And big systems like NASA and JAXA from Japan, they have been sending up some of these amazing space-based observatories for a long time. And ESA, for example, from the European Space Agency. Now, India starts getting into this only in the last few years. And the Chandrayaan mission and Aditya are part of that. Just extends India's interest in producing these amazing space vehicles that can go and explore the solar system, but with now scientists taking an active interest in it and giving it purpose.
Yes, that was my next question, actually. So we're speaking a month to the day that Aditya launched, I think. That's a solar observatory. Can you tell us a little bit about that?
Yes, and I'm very excited about it. I was there at the launch of Aditya L1. So
tell us a little bit about the launch, actually, if you wouldn't mind. Where was it?
I was launched from the same Satish Dhawan launching pad in the eastern coast of India from Sriharikota. And it's a very complex launch because Aditya L1 goes not around the Earth, but eventually when it reaches there in 4 months' time, it'll orbit the first Lagrangian point, which is about 1% of the way to the sun. So in the Earth-Sun system, there are these 5 parking spaces called the Lagrangian points, where if you put a satellite, it stays there because the gravitational force of the Earth and the Sun on it balance out. And so the first Lagrangian point is somewhere where this mission is going, and that's where it can stay for a long time and it can monitor the Sun 24 hours without going into the Earth's shadow. So once it gets there, and using 2 instruments, one is images the disk of the Sun at the highest resolution so far done in the ultraviolet. So in the ultraviolet, sun is very active. It doesn't look very like a boring yellow disk. It actually, in the ultraviolet, you can see constant solar activity happening on the surface of the sun, because the sun is very highly magnetic on the sun, and so there are magnetic storms going on all the time, and you can image them. These storms then generate a lot of charged particles that are ejected into its corona. The corona is many times larger than the sun itself. And the interesting thing is that the sun's surface is about 6,000 degrees, but its corona is more than 1,000,000 degrees hot. And we don't understand why the surrounding the sun, which stretches to about 5-6 times the size of the sun, is 1,000,000 degree hot plasma. And it's full of charged particles that come out of these solar storms. Now, a lot of these then travel to the Earth, and these are called coronal mass ejections that travel all the way to the Earth. Of course, it goes everywhere in space, but the ones that come to the Earth are responsible for causing the aurorae near the poles. So it's beautiful. But on the other hand, as these charged particles come and bombard the Earth's atmosphere, it hits a lot of our communication satellites, anything that's in the upper atmosphere, and causes damage. So as the number of things that we are dependent on, which are in orbit around the Earth, increases, it is very important for us to know how the sun's activities affect the Earth's atmosphere.
And that's what Aditya is going to be doing.
Exactly. To monitor what's called solar weather.
Pun not intended. What was the atmosphere like when the probe left the Earth?
Oh, that was wonderful. And so, I mean, this was my second launch from the same place. I was there at the Astrosat launch 8 years ago, but this was wonderful. It's a great experience. You take part in the countdown indoors. You're sitting in the control room looking at the countdown, and then a minute before the launch itself, you rush out to the terrace to see the thing coming up, and it's very loud. And seeing a launch and being there is a wonderful experience. And of course, then you have your fingers crossed for an hour or so and hope that it will actually go through all the different stages that he has to go through by shedding different parts of the rocket, and finally the satellite going into free space.
Now, slight change of tone, but I'm really interested in your opinions on this. One of the things that have really come out of our reporting on India so far for this special on India is the sense of brain drain, the sense that whilst India awards lots and lots of PhDs to people, a lot of those people then leave and go elsewhere and take that training and education with them. Now, it strikes me, and I know we've spoken about this before, that big international reputation and international programs like India's space mission might be a really powerful way to retain that talent or to draw talent back into India. What do you think about that in your position as a vice-chancellor of a university?
It's a very important part of it. I mean, in my generation, when we went into university, we knew that if one had to do research at or even work at the forefront of these technologies, one had to go abroad. And I went to the UK to study, and then went and worked in the US and worked for agencies like NASA and ESA and things like that. And if you look at the forefront of scientific research in most subjects, and certainly in space and astronomy, you would find a large number of Indians working all across the globe. That's because India's science training, the universities are very, very robust, very good, and so highly trained people without any opportunities going around the world. I think that's what the brain drain is. Now, one of the things that struck me most in the Chandrayaan-3 launch and then the Aditya L1 launch is that this is the first time ISRO had done a public exercise in inviting the media into these events. I don't know, till now, many of the activities of ISRO had really not been media friendly. And when I went out there, and in my university, students were watching it live on big screens. It was actually on YouTube Live, the most popular ever live program on YouTube, if you look at the number of people who watched it so far in the history of YouTube. And you could see that in the streets. You could hear kids celebrating on the streets as if India's just won a cricket match. You're hearing that kind of cheers from the streets of India. That itself shows not just the common people are involved in it. The next generation of students, people who are going to do all this, are getting involved in what they see are achievements of Indian science and technology. This itself is very, very important. And the fact that one actually starts to feel that you can achieve such things in India I think it's going to be very important. I mean, the brain drain works in both ways. People go to train abroad, but they never come back. And there are whole generations of students who don't think that it's worth studying for higher, very technical subjects in India. I think what will happen in the future is that a lot of people will study at Indian universities who want to do this kind of thing, will remain in India, not go abroad. And people who have gone abroad for such training will come back.
Have you noticed that already at Ashoka University?
Well, one of the reasons we are here at Ashoka University is that we're trying to build an international university here in India. In the private sector, Indian education has largely been government supported. And in the private sector, now universities like Ashoka can actually have an international presence. At Ashoka here, I have students from 20 different countries. 20% of my faculty are non-Indian, and this is increasing. And almost all the faculty that I have, about 200 faculty on campus, have had their last jobs abroad. So a lot of people are here who have gone abroad and then come back, and we're attracting people who are non-Indians who want to work in India. And this, I think, hopefully sets a trend in academia.
And that sense of internationalism, that sense of joining the larger international community when it comes to these big scientific projects, that's not just limited to space. I think it's where India really shines, but I'm sure there's lots of other projects outside of space science where yes, something similar is happening.
This is also quite new in Indian science. I mean, I think, again, when I went to university, Indian science was not part of international science, the big science projects. But now, in almost all subjects I know, India is actually formally at the government level part of large projects. India is part of the fusion energy project ITER, which is based in France. In astronomy, India is part of the Square Kilometre Array and the 30-meter telescope and the Gravitational Wave Observatory, LIGO. These are all big projects that involve many, many countries all over the world. And India being part of it, Indian scientists are becoming part of big projects that are going around the world and interacting directly with the international community, but being members of Indian institutions. And this, of course, is a trend, and the space industry and space research is just a part of the whole thing. And so you have to see that in context of India's growing globalization of all kinds of academics.
That's a real rosy picture of Indian academia and moving into the international community. But are there any sort of pain points, or is there anywhere that needs to get better?
I mean, by no means am I saying that we've arrived. I mean, I think there's still a long way to go. There's been a tradition of very good university education and research in India, but they've been separate. I mean, in India, research happened in research institutions, and teaching happens in universities. Very few universities do research, and very few students going to universities see research being done. And one of the major things that's happening in India is to bring the two together. My university, Ashoka, is one of very few universities that has both together. So the people who teach also do research. But in an overwhelming fraction of India's 1,000 universities, the faculty don't do research. So that is one of the important things. I mean, even to reverse brain drain, one needs to have students go through a program of research and teaching at universities. This is the big goal, I think, in kind of remodeling Indian university education. That's happening. The national education policy that was unleashed on the country in 2020 talks about this, bringing research and teaching together. It is a big task. India is a large country, and the number of colleges and universities is mind-boggling. But incidents like successes with the space program, successes with the attempts to globalization, they all help in providing motivation to this much larger system.
And actually on that, what are your hopes for the future, both for space science and maybe also Indian science in general?
I have very high hopes for the way things are going. I think one of the major challenges is to, as I said, bring research into the universities so that improves the level of education, because people who are creating knowledge in research are also giving that knowledge to the students. Then there's a very ambitious program going on in bringing women into higher education and science in particular. And this is another big thing. Of course, as I said, the numbers are mind-boggling. But of course, half that number are women, and the number of women in Indian science is still particularly away from the major cities, is something that needs to be improved. So that's another big challenge. But I think we are just about a generation away from India becoming one of the major leaders in world academics. Already, the number of papers coming out of Indian science is on the top 5 in the world. Now, the quality of those papers needs to improve. The amount of money that the government spends on Indian higher education is still much, much below the average of the countries that are very active in science. That will have to improve, but India is trying very hard to bring actually private money from industry into Indian science and university education, university research. So that will help. So I'm very hopeful that the brain drain problem that we're talking about will be reversed, but also in some key subjects, India will become the place where the world's scientists will come and work.